Hello dear students, in this session I have taken few good previous year problems of JEE Mains. These questions I got while having discussion with my students. So I thought I should be sharing these questions as well as their solutions. What I have done, I have taken few problems per topic so that you do not get many problems in one topic and some topics are left out. So in this session you will get a balanced set of problems that may be useful for your upcoming JEE Mains exam. So let's start. So this is me, Surender Jain. I am teaching maths for last 14 years. I am teaching maths for mains, advanced and other Olympiad exams as well. So let's start with this question. Here we are given A1, B1 as 1, 1 and AN and BN are given as a recurrence relation. Then one summation S and one summation T also defined in terms of BN and N. Now they are asking the relation 2S minus T. So what I will do, I will start with S and then we'll see how much BN and how much AN is needed, and accordingly we will find the expression for AN and BN. Okay, so first I will write S by expanding. So S will be equal to, I think this is B1 upon 2 plus B2 upon 2 square plus B3 upon 2 power 3. I will write few more terms to explain you it better. So 4 terms I am writing it here, and then the last 2 terms, that is B9 upon 2 power 9 plus B10 upon 2 power 10. Okay, now if I multiply this S by 1 upon 2, so we will be getting S by 2, and that's a very common trick while doing questions like AGP or difference method. In AGP you multiply by common ratio. So here although B1, B2, B3 are not AP, but difference of B and then difference of A is definitely AP. So the same trick will apply here as well. So if you take the difference, we will be getting B1 upon 2 power 2 plus B2 upon 2 power 3 plus B3 upon 2 power 4 and so on. This B9 below it will be B8 upon 2 power 9 plus B9 upon 2 power 10 plus B10 upon 2 power 11. Okay, now if you take the difference, we will be getting S upon 2 and that will be equal to B1 upon 2. I think B1 can also be written as 1 plus. Now if you take 2 power 2 LCM, then B2 minus B1 using this will be just A1. So A1 upon 2 power 2 plus A2 upon 2 power 3, likewise plus A3 upon 2 power 4 and so on, A8 upon 2 power 9 plus A9 upon 2 power 10, and this will be written with minus sign, B10 upon 2 raised to the power 11. So this is what we are getting for S by 2. Now once again if I do the similar thing, so I will be multiplying by 1 by 2, so it will become S upon 2 power 2 and that is equal to B1 upon 2 power 2 plus A1 upon 2 power 3 plus A3 upon 2 power 4 and so on. This A7 will have, A8 will have A7 upon 2 power 9 below it plus A8 upon 2 power 10 below it. So A7 below A9, A8 below A9, and this A9 will be A9 upon 2 power 11 will be below this B10 minus B10 upon 2 raised to the power 12. Okay, now if we take the difference here, now that is very important step here after this. If you take the difference, I will use this space to write after this. So if you take the difference, so this will be just S upon 4 here. Okay, now this B1 by 2, I will write the value, so 1 upon 2 only, plus this A1 and B1 are same, so they will be cancelled, so 0 here. Now A2 minus A1, A2 minus A1 if you use here, it will be just 1. So this becomes 1 upon 2 power 3 plus, then if you take the difference of A2 minus, I think I have written it wrong, it should have been A2 here, yeah, A2. A3 minus A2 will be just 2 upon 2 power 4, okay, and so on. And here it will be 7 upon 2 power 9 plus 8 upon 2 power 10, and then this will subtract this, so this minus this if you do, this will become plus here, but it is having 2 power 11 power, so finally it will be B10 upon 2 power I think 12 and minus A9 upon 2 power 11. So this is what we are getting. Now please look at this very carefully. I think these terms are having some connection with this capital T here, 1 upon 2 power 3, whereas this is 1 upon 2 power 0, then 2 upon 2 power 1, this is 2 upon 2 power 4. So from this if you take 1 upon 2 power 3 common, okay, if you take 1 upon 2 power 3 common, I think this becomes just T. This entire bracket becomes T minus B10 upon 2 power 12 minus A9 upon 2 power 11. Okay, this remaining calculation I will do in the next slide. So now you can see if I bring this t upon 8 on the left hand side, I think this will become 2s minus t type term. Okay, so we will be getting, if I bring that thing, just 1 minute. Yeah, so this t upon 8, if I bring it here, it will become 2s minus t upon 8, 2s minus t upon 8, and that will be equal to 1 upon 2. That will be equal to 1 upon 2. And this will be b10 upon 2 power 11, b10 upon 2 power 11, and I think a9 upon 2 power 11. Just 1 minute, 11 or yeah, 11 only, but I think this is 12 here. This is 12 here. Okay, now they are asking 2 power 7 into this thing. That means to make this 2 power 7, I will be multiplying this entire equation by 2 power 10. So 2 power 7 into 2s minus t will become equal to 2 power 10 when multiplied this side will be 2 power 9 here minus b10 upon 4 minus a9 upon 2. So this is what we are looking for. Now the important thing is how to find b10 and a9. Okay, so one of the method could be that you continue doing this way. Okay, from a1 we already know, so use this, so you find a2, then a3, and so on. Numbers are not that big, that can also be done, but the proper method would be that you know a2 minus a1 is equal to, I think, 1. Let me check. A2 minus a1 is equal to 1, and likewise a3 minus a2 is equal to 2, and so on. So general term, if I am looking for an, that will be given by n minus 1 here. If you add them, I think this becomes telescopic sum, so these terms will get cancelled. So this a2 will get cancelled, a3 will get cancelled, an minus 1 will also get cancelled. So what we will be getting? We will be getting an minus a1, that is given to us as 1, and that is sum of n minus 1 natural numbers. So n into n minus 1 upon 2. So this is the expression for an. So we can find a9 definitely. Here we can write an also as nc2 plus 1, although there is no advantage of it. Although if you have gone through my earlier video on sum of n terms, I have told you when difference is AP or difference is AP, how we can find nth term and sum of n terms in terms of nc2, nc3. So if you know that thing, I think this can be done directly also. Okay, I will avoid talking about that here, but if you want, you can go to that video also. Now similar to this approach, I think we will be getting b2 minus b1 is equal to 1, a1 actually. Let me see, b2 minus b1 is equal to a1, and b3 minus b2 is equal to a2, and so on. bn minus 1 will be equal to an minus 1. If you add all of them similar to this thing, we will be getting bn minus b1, that is 1 only, and that will be summation of a1, a2, a3, an minus 1. That means summation of this or summation of this, you can say. Now these are total n minus 1 terms. So for this one summation will be just n minus 1. Okay, whereas the summation of n into n minus 1 by 2 can be done in two ways. One by telescopic sum also, or by applying sigma also. Okay, now if you do it by telescopic sum, I think there is a direct result. It will become n into n minus 1 into n minus 2 upon 3. Okay, what is the trick here? Trick I will tell you later, but let me complete this question. So this bn will become equal to, I think 1 will cancel, and that will become n plus nc3. You can write this as nc3 also, or like this also you can write. Now we will be able to find now b10, that is 10 plus 10c3, which is I think 120, 10 into 9 into 8 upon 6, yeah, 120. Okay, so this is 130, and a9 if you have to find, so a9 will come from this nc2, 9c2 plus 1, 9c2 is I think 36, 36 plus 1, 37. So what is my answer? 2 power 7 into 2s minus t will be equal to 2 power 9 is I think 512, b10 is 130 upon 4, that is 65 upon 2, and minus 37 by 2. Okay, so this becomes 512, 65 and 37 is 102, so this becomes I think 51. So if you subtract it, you get 461 as the answer of this question. Okay, so this was a big question, no doubt about that, but this is how you can solve it. I hope you have understood it, and I feel this kind of question can be asked in JEE Mains once again, maybe not completely but in parts. Maybe they may ask a small part of this question, but this question has got many things to learn. So please go through this question completely. So answer for this will be 461. One more thing I was talking about, that was that if we found an is equal to 1 plus n into n minus 1 by 2, how to find the summation of a r, where r is going from 1 to n minus 1. I think this is how I found bn. This was my bn. Okay, plus 1 was also there in bn. Okay, so how you can find it? So for 1, I think it is directly n minus 1. But for this part, what I will suggest, write this as, for r you will be writing r into r minus 1 by 2. Okay, and when you are having a sequence where two terms in AP are multiplied and such summation is sought, what you can do, you can multiply this by one term before this, so r plus 1, and one term after that, and take their difference, and this difference will always be constant, so you just have to divide by 3 here. Okay, now if you use this, so your bn will become equal to n minus 1 plus this will be 1 upon 6 outside, and summation of, you can write it as r plus 1 into r minus 1 minus r into r minus 1 into r minus 2. Now r is starting from 1 going till n minus 1. Now if you keep putting the values of r as 1, then 2, and so on, you will see these two terms are making a telescopic sum. So from that you will get this answer to be directly n into n minus 1 into n minus 2. I am not doing it completely. Please put these values of r and you will get this answer. So this is exactly what I got. And in this bn, I think plus 1 was also there. Bn, I think this plus 1 was also there. So this plus 1 if you do, so this 1 will get cancelled. So you will be getting n into n plus nc3 for this bn. Okay, so this is one question. Now coming to the next question. This question is again from sequence and series only. Let first term of a series be t1 is equal to 6 and rth term tr is equal to this thing. Then sum of first n terms of this sequence is, then n we have to find. Dear student, I will tell you this question two methods. First method is using telescopic sum. So we are given t2 minus 3t1 is equal to 6 power 2 if you put r is equal to 2 here, and then t3 minus 3t2 is equal to 6 cube, and so on. Tn minus 3tn minus 1 will be equal to 6 power n. Okay, now dear students, if this summation was going till infinite, we do not know whether this series, this summation till infinite will converge or diverge. But if it was converging series, and we could have taken sum till infinite, because in some questions of JEE Mains also they have asked sum till infinite, then adding this and adding this will give you similar sum, because last term will not matter. Okay, this will be t2 plus t3 plus tn up to infinity. So the sum till infinite, if it was, so this will be s minus t1, whereas this will be minus 3 times s or s infinity, you can say. So if this question was asking sum till infinite, I think this would have been the approach. But fortunately or unfortunately, whatever you say, here they are saying sum of n terms, and n is not infinite. So what I am going to do, I will be multiplying this by 1, this by 1 upon 3. I have to write one more term so that I can explain you why I am doing this thing. T4 minus 3t3 is equal to 6 power 4, and for this I'll be multiplying by 1 upon 3 power 2. Now please see, if you do this multiplication and add, this t2 will be just t2. When you multiply 1 upon 3 to the second equation, it will be minus t2, and when you adding them, this t2 will get cancelled. Now after multiplication with 1 upon 3, this t3 is now 1 upon 3 into t3. Now if I multiply the third equation by 1 upon 3 square, this will become t3 upon 3. So t3 upon 3, t3 upon 3 will get cancelled, and so on. You can check, all the terms will get cancelled, only the last and this t1 will remain. Here if I'm multiplying this t3 power 1 with this t2 here, okay, t3 power 2 with this t3 here, I think this will be 3 power n minus 2 if tn minus 1 is here. You can look for the pattern from anywhere. If you look at the pattern from this 6 power, then also you can find this is 6 power 2, this is 3 power 0, 6 power 3, this is 3 power 1, and so on. So this power is 2 less than the power of 6. So here it will be 3 power n minus 2. Now if I add all of them, I will be getting just tn upon 3 raised to the power n minus 2. Okay, and minus, I think, just 3 times t1. And on the right hand side, if you look at this, it is, if you take 6 power 2 common, okay, this will be just, I think, 1 here, plus here it will be 2, then it will be 2 square, and so on. The last term will be, I think, 2 power n minus 2. So total number of terms here would be n minus 1. You can look from this also 1, 2, 3, and this is n minus 1. So total number of terms n minus 1. So what we are getting? We are getting Tn upon 3 raised to the power n minus 2 minus 3T1. T1 we are given as 6, so minus 18, and that will be equal to 36 into 2 power n minus 1 upon 2 minus 1. Sum of n minus 1 terms of a GP. So this Tn will become equal to 3 power n minus 2 into 36 into 2 power n minus 1 minus 36 plus 18. Okay, I think after simplification, because this will become 2 power n and this will remain 18. From 18, 9 I will take it here. So 2 into 6 power n will be here minus 1 minute. I think I am doing something wrong. Yeah, I am doing this. 1 minute. This 18 actually will be added inside the bracket. So minus 18 it will be. So minus 18 into this thing, there will be minus 18. So I can take 9 again outside. So only 2 will remain. 2 into 3 power n. So this is what we are getting as the general term of this Tn, and you can verify that this will satisfy this recurrence relation also. Now they're asking the sum of n terms of this series. Okay, now sum of n terms of this series means, let me do this on the next slide. So Tn we got as 2 into 6 power n minus 2 into 3 power n. Let me check. 2 into 6 power n minus 2 into 3 power n. So summation, this was Tn. This was Tn. Now summation of n terms will be 2 into summation of 6 power n minus 2 into summation 3 power n, and these will be two simple GPs. So this will be 6 as first term, 6 power n minus 1 upon 6 minus 1, so 5, minus 2 into 3 power n minus 1 upon 3 minus 1, so 2 you can write. So 2 will be cancelled here, and we can take 1 upon 5 as LCM. 1 upon 5 is taken LCM, so 6 into 2, 12 into 6 power n minus 12. Okay, and here this 5 will be multiplied with this 3, so minus 15 into 3 power n plus 15. Okay, so we are getting 1 upon 5 into these two things. If you write minus plus 3, it will become, okay, so what they are saying, let me see, 4 into 6 power n minus 5 into 3 power n. So I can take 3 common, so that will be 4 into 6 power n minus 5 into 3 power n. Let me check, it was 5 only, that's correct. And here it is plus 3, so plus 1 it will be if you take 3 common outside. Okay, so if I compare with this thing 1 upon 5 and this thing we are getting as it is, only this bracket is actually equal to 3 if we compare it directly. So what we will be getting, so n square minus 12n plus 39 is equal to 3. I think this gives you perfect square of n minus 6 is equal to 0. So the value of n has to be 6. So answer of this question is 6. Okay, so that is the question. Yeah, I was talking about one more method to find this Tn. Now dear students, let me tell you, if you have done the characteristic equation to solve recurrence relation, so there are two things. One is Tr minus 3 into Tr minus 1 with Tr and Tr minus 1, and then there is another thing that is known as particular thing or particular solution for this recurrence relation. From this you should be getting the characteristic equation as x minus 3. It will be just 1 degree, so x minus 3 equal to 0 gives you x is equal to 3. So corresponding to this part, your solution should be Tn is equal to a into 3 power n. That is for what? This is only for this Tr minus 3 into Tr minus 1, but because we are having 6 power r also on the right side, which is nothing but a GP, so this will give you another term in the solution, that is b into 6 power b into 6 power n. Okay, now to find these a and b, what we can do, we can use T1, which is given as 6, so that will be a into 3 plus 6 into b. Dear students, you can find T2 using this, but I will suggest you find T0. Although they are saying r start with 2, but in such relation T0 also works well. So just put r is equal to 1 here. So this will be T1 is equal to 3 times T0 plus 6 power 1. Okay, and T1 is 6, so T0 will be 0. So T0 is 0, so here it will be a plus b. Now if you simplify this, I think you will be getting a as, if you multiply this by 3 and subtract, so 3b will be equal to 6, so b is equal to 2, and I think a is equal to minus 2. So this is what we are getting. I think same thing which we got from that method also. Okay, so this question I think you will like to do by method 1, because if you're not aware of this thing, if you're not very comfortable with this, then go with method 1 only. Okay, coming to next question. This question is given alpha beta are the roots of this quadratic, and we have to find this expression. One very good question. I have seen many students having doubt in this, many students. So please see how this question can be done. We are given this quadratic x square plus root 6 into x plus 3 equal to 0, and its roots are alpha beta. Now you can see alpha plus beta is equal to minus root 6, where alpha beta is equal to 3. Now from this we can see alpha square plus beta square coming out to be 6 minus 6, that is 0. Very interesting thing. Sum of squares of roots is 0. That means root has to be imaginary, which can be checked from here also. Okay. Now what I will be doing, alpha square beta square, also we know it will be equal to 9. Okay. So now we get a quadratic whose roots are alpha square beta square, and then this quadratic will be just x square minus 9 equal to 0. Please understand, x square minus 9 is equal to 0 will be a quadratic whose roots are alpha square beta square. Sum is 0, product is 9, actually plus 9, not minus 9, plus 9. Okay, why I am doing this thing? Please see here the expression is given as 23, 14, 10, 15. The difference of these two is 8, difference of these two is 4. So something related to, you know, this kind of sequence where Sn is equal to alpha n plus beta n will be needed, where difference of where the values of n are 10, 14, 15, 23, etc. Okay, now please see in this equation, because alpha square beta square are the root of this, so I can write this as alpha power 4 plus 9 equal to 0 and beta power 4 plus 9 equal to 0. Okay, now if you multiply this by alpha power n and this by beta power n and add them, I think we will be getting Sn plus 4 plus 9 into Sn is equal to 0. So what we are getting a relation of, you know, Sn with Sn plus 4, or you can say Sn plus 4 with Sn. So I will be getting a relation of this S14 with S10 and this S23 with S15. Now the interesting thing here is S2 is already 0. Okay, so if you put n is equal to 2, will make S6 also 0, will make S10 also 0, S14 also 0. So these two, 14 and 10, are just 0, 0. Okay, then we are looking for relation between S23 and S15. So S23, if we are looking for, that means I will be putting n is equal to 19. So n S19 plus 9 into S19 will be equal to 0. Okay, so S19 is equal to minus 9 into S19. And if I repeat the same process, so it will be minus 9 into S15. So we are getting 81 into S15. So this S23 upon S15, the value is 81. So answer of this question will be 3, that is 81. I think this way this question is done very fast. There has been many questions. I could not bring all the questions here in the session, but I have seen many questions where they are asking you to use this kind of recurrence relation of Sn with Sn plus 4, etc. Okay, so this is one very important, and this is also known as Newton's identities for polynomial. I have done one video on Newton's identities on polynomial also. You may like to go through that also. You will find all the details about that Newton's polynomial. In fact, this is one simple version. You will find some other special cases also in that session. Okay, now coming to the next question. So here the answer was 81, that is 3. Now question number 4. We are given S as 1, 2, 3, 4. Then number of elements in the set. Yeah, this is a question of function. Now the interesting here is that the domain is not ordinary set S. It is rather Cartesian product of this S with itself. That means its element will be 1, 1, 1, 2, 1, 3, 1, 4, okay, 2, 1, and so on. I will not write all of them. In the last you will be getting 4, 4. So total 16 element will be there in S cross S, and this function is defining these ordered pair into the set S itself, set S. Okay, and this function f is onto, so its range has to have all the elements 1, 2, 3 and 4, and additionally they have given fa comma b is equal to fb comma a, and that is greater than or equal to a for all AB belongs to S cross S. So dear students, from this what we can conclude directly, that we will be getting f of 1, 2 equal to f of 2, 1, etc. Okay, and that has to be bigger than 2, actually greater than or equal to 2, because any element you can treat as A or B here, but if it is true for A, so I will be taking 2 here, so it should be greater than or equal to 2. Now please understand, please listen carefully. All these ordered pair which are having 4 in it, first of all this value will be equal to 4 1 also. Now using this greater than or equal to a thing, I think that has to be greater than or equal to 4, and because in this codomain only 4 is there, no 5, no 6, no bigger element than 4, so this means my f1 comma 4, f4 comma 1, this has to be equal to 4. And not only this, all these kind of ordered pair like 2 comma 4, 4 comma 2, okay, similarly 3 comma 4, 4 comma 3, and also 4 comma 4, all these values will be equal to 4 only, no other value is possible here. How many ordered pair will be there with 4? I think if with 4 you will be having 3 into 2 6, 6 plus 1 7 ordered pairs. So here you can check, there will be 7 values that should be mapped, 7 ordered pair should be mapped to 4 only. You can check 1 2 3 1 2 3 4 5 6 7, yeah, 7 ordered pairs are mapped to 4 only. So that means 4 is definitely there in the range, because without 4 having in the range, this condition will not be satisfied. So to make it onto, I think I don't have to be worried about 4 because 4 is already there in the range. Now one more thing, that f11, please listen carefully. F11, although it has to be greater than or equal to 1, it has to be greater than or equal to 1. So it can be 1 also, it can be 2 also, it can be 3 also, it can be 4 also. But other elements like f1 comma 2 or any other values, any other ordered pair like 1 comma 2, 2 comma 1, they have to be greater than or equal to 2. So there cannot be any ordered pair other than 1 comma 1 that can have a value equal to 1 because of this condition. So here because of this thing, because we want this to be onto, so this value has to be equal to 1 only. This value has to be equal to 1 only, because if this is not 1, no other ordered pair can take value equal to 1, and we want this to be onto, so f11 will be equal to 1. So 1 is taken care of, 4 is taken care of, we just need to take care of 2 and 3, that's it. Okay, now let's see what are the remaining ordered pairs. If I look for those ordered pair which are having 3 in it, so f1 comma 3, f3 comma 1 will have same value, f2 comma 3 and f3 comma 2 will also have same value, and similarly f33 will also have some value. Now these values can be either 3 or they can be 4, because they have to be greater than or equal to 3 as per that condition. Okay, similarly if I look for 1 comma 2 and 2 comma 1 also and 2 comma 2 also, okay, these values can take value 2 3 or 4, 2 3 or 4. Okay, anything remaining? I think I have already taken care of 7 ordered pair here and 1 ordered pair here, so 7 plus 1 8 ordered pairs are taken, and this is 7 again, so 8 plus 7 is 15, sorry 8 plus 5, 8 plus 5 13, 13 plus 3 13, 13 plus 3 16, sorry. So all the ordered pairs I have considered. Now it is not mandatory this should take value 3 or this should take value 2, because maybe this take value equal to 4 and these are taking values 3 and 4, 3 and 2 respectively, then also it can be made as, you know, onto. So what I will be doing, I will find number of onto functions using inclusion exclusion principle. Please see how. So first of all, if I look at those functions, all those functions in which these two values can have value from 3 to 4, these two can have from 3 to 4, and this can have from 3 to 4. So that means these two, because they have to be same value, this is having 2 options, this is also having 2 options, and this is also having 2 options, so 2 power 3 into this element, or this value is having 3 options, so 3, this is also having 3 options, so 3 power 2. But in this case, if you go for all this kind of functions, there are chances when some of the values are not there, some of the functions are not having 3 into the range, or some of the functions are not having 2 into the range. So I will subtract those cases when those functions not having 2 in range. Okay, then minus those functions not having 3 in the range, and then plus those functions not having 2 and 3 both in the range. See, when you are subtracting those not having 2 into the range and subtracting those not having 3 into the range, I think you are subtracting double those cases when 2 and 3 both are not there in the range. So we do the addition here, and that is actually the fundamental thing of inclusion exclusion principle. Now please see how this calculation can be done further. 8 into 9, 8 into 9, 72. Okay, now when 2 is not in the range, that means here there will be no change, so this will still be 2 power 3. If 2 not in the range, so this value will be either 3 or 4, this value will be either 3 or 4, so only 2 power 2. Instead of 3 power 2, it will be 2 power 2 minus, when function not having 3 into the range. If 3 not in the range, so these will be having only one option, this will be having 4, this will be having 4, this will be having 4, so minus 1 power 3. If 3 not in the range, so this will have two options, 2 4, this will have 2 4, so 2 into 2, 2 power 2. And then both 2 and 3 not in the range, that means this will be having value 4, this will be having 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 4, because neither 2 nor 3 is there in the range. So here I think 1 power 3 into 1 power 2, you can say. So 72 minus this becomes, I think, 32, yeah, 32, and this becomes 4 and plus 1, so this becomes 40 minus 4, 36, plus 1, 37. So this is the answer of this question. Okay, interesting question. The condition what they have made, first of all, that is not very easy to comprehend in the exam. Okay, it will take time. Maybe for such kind of question you should have spare time, 2-3 minutes, or I will say at least 5 minutes you should have spare for such question, because first comprehending the question and then thinking that how it will be done, it will take time. Okay, this inclusion exclusion is the best way, or some of you may be making cases then which one will be having 3, which one will be having 4, so that all the elements are there in the range, but that is not very systematic. This one I feel is the best method for this question. So answer was 37 of this question. Okay, so this question number 5. Here this question is from trigonometry. X and y are between 0 and pi. Cos x plus cos y minus cos of x plus y is equal to 3 by 2. Then we have to find sin x plus cos y. See here, this question, when I did first, I did not do it in the best method, I will say. This I did it by AOD. Okay, because I was thinking of some maximum value, minimum value should come directly from trigonometry, using like cos is taking value between 0 to 1, sorry, minus 1 to 1. And similarly sine taking value between 0 to 1 in this range. So I was applying that thing, but I could not do it. But later on I found one very good method using trigonometry also, and then AOD also. So I will do first by trigonometry. So apply cos c plus cos t formula here. So we will be getting 2 cos x plus y by 2 into cos of x minus y by 2. Whereas minus and this thing, it will be minus 2 cos square x plus y by 2 minus 1 is equal to 3 by 2, is equal to 3 by 2. Now let me take this cos x plus y by 2 as capital C. Okay, so this is also same thing, cos is, this will be c square. So we will be getting 2 cos square, if I take this on the right side, minus 2 into cos x minus y by 2 into c. Okay, and minus plus, if it is going that side, it will be plus 1 by 2 equal to 0. Okay, multiply by 2. Okay, will give you 4 cos square minus 4 cos x minus y by 2 into cos plus 1 is equal to 0. Now you can see I can write this as 2 cos, capital C is cos x plus y by 2, so 2 capital C minus, I can write this as cos of x minus y by 2 whole square. So you can see 4 cos square minus 4 capital C into this thing, and for that I will be subtracting this cos square x minus y by 2, and that equal to 0. Okay, now you can see these are two positive things. This is perfect square, so positive, and cos square cannot take value greater than 1, so this is also positive, or in worst case 0, and the sum is 0 indicates both of them should be 0 0 only. So let me do it here. So first of all we will be getting cos of x minus y by 2 equal to 0, and this capital C, that means cos x plus y by 2 will be equal to cos of x minus y by 2 divided by 2, that is 1 upon 2 only, because from this we are getting, sorry, not 0, from here we are getting this to be 1. Now if it is 1, so x will be equal to y, because x and y both are between 0 to pi, so you cannot have 2 pi minus 2 pi 4 pi, so only 0 can give you this cos value equal to 1, so x is equal to y, and if x is equal to y and cos of x plus y by 2 is equal to 1 by 2, so x plus y by 2 has to be equal to pi by, I think, 3. So solving this we get x equal to y equal to pi by 3. So both x and y are coming out to be pi by 3, only no other option is possible. So here sin x plus cos y means root 3 by 2 plus 1 by 2, so answer of this question will be B. So that is one method. Not very difficult. I think this kind of questions you might have seen in books also, so can be done, but still in exam pressure I will say not very very straightforward. Now please see the method 2. So the method 2 will be cos of x plus cos of y minus cos of x plus y. Okay, so I am taking this as a function, I am taking this as a function of x and considering y as a constant. considering y as a constant. Now if you differentiate it, f dash x will become equal to minus sine x plus sine x plus y. We are considering y as a constant, so differentiation of this will become 0. Okay, now to get the point of maxima or minima, this will be 0 and this will be 0, means sine of x plus y is equal to sine of x. That means x and x plus y, they should be complementary to each other, because these x and y are within 0 to pi, so no other possibility is there. Either they will be equal, then y will be 0. Okay, and for y equal to 0, I think it is not possible, so this is a possibility. So x is equal to pi minus y upon 2. Okay, also you can see using first derivative test, this is 0 here, this is pi by 2 here, and this is pi here. Okay, so this pi by 2 minus y by 2 will be lying somewhere here. Okay, and you can check that between 0 to this thing, your derivative, if you put x is equal to 0, sine y will give you positive, and within this range, when you put x is equal to, let's say, pi, this will be 0, this will be negative, so here negative. So this point is a point of local maxima. This is a point of local maxima. Capital M I always write as a local maxima. Now you can find what will be the maximum value. If I write x is equal to pi minus y by 2, your function will become, I think, sine y by 2 plus cos y, and this will become, I think, x plus y will become pi plus y by 2, that means minus minus plus sine y by 2. Cos y by 2 you can write minus 2 sine square y by 2 plus 2 sine y by 2 plus 1 will be there. Okay, now you can see this will be a downward parabola in terms of sine y by 2. If I take sine y by 2 as, let's say, capital S, so 2s square plus 2s plus 1. So in terms of sine, it will be downward parabola whose maximum value will come at 1 upon 2, I think, minus b upon 2a, so 1 upon 2. Okay, and the value of sine y by 2 for y between 0 to pi by 2 will be between 0 to 1 only, so 0 to 1. So the maximum possible value of this is at 1 by 2, and if you put 1 by 2, you will be getting this coming out to be 3 by 2 only. Let me check once again. 1 by 2, so this is minus 1 upon 2 plus 1 plus 1, so 2 minus 1 upon 2, so 3 by 2, that is correct. So that is the maximum possible value of this function, and we are given this expression is equal to 3 by 2 only, which will be possible if, so I will be writing it, so fx is equal to 3 by 2 only if we take y equal to, y means sine should be equal to 1 upon 2, sine is equal to 1 upon 2 means sine y by 2 is equal to pi by 6, so y is equal to pi by 6, pi by 3, and x also, if you put it here, you are getting same value, pi by 3 only. Okay, so same thing we are getting from method 2 also, but I think method 1 is better. If you can think of that method directly, so method 1 is definitely better. Okay, so answer of this was B. Coming to the next question, but before that, dear students, I am sharing with you these QR codes of Eklavya JEE Mains test series and Eklavya Telegram channel link. Just join these things as soon as possible. Question number 6. We are given a sequence, and sequence is 2n square plus 3n plus 4 upon 2n factorial, and they are asking the value in terms of e. Now dear students, I have seen a pattern in last 3-4 years, including JEE Advanced, JEE Mains. They are asking questions based on expansion of e power x, cos x, sin x. Cos x, sin x expansions they are using in the questions of definite integration, and this kind of questions I have seen in JEE Mains 2-3 times. So please take care of this kind of questions, how these are done, please see. So here what I will do, I will expand it. I can do it in 2 ways. One of the student suggested me, and I think that is a better method. 2n you take as t, so this entire thing inside will be written in terms of t. It will become t square upon 2 plus 3t upon 2 plus 4 upon t factorial. Here n is starting from 1 to infinity. I will come back to n after few steps, so I am not writing limit here in terms of t. So this will be equal to, you can write summation this t square upon 2, so I can write this as t upon 2 into t minus 1 factorial. Here this you can write it as 3 by 2 1 upon t minus 1 factorial plus 4 upon t factorial. Okay, now I will write this t as t minus 1 plus 1, t minus 1 plus 1, and split it into 2 parts. We will be getting this as t minus 1 upon this thing means 1 upon 2 into t minus 2 factorial plus 1 upon 2 into t minus 1 factorial, and this 3 upon 2 is also there, so I think we will be getting 2 upon t minus 1 factorial after combining it plus 4 upon t factorial. Now I will write this t as 2n, So 1 upon 2 into 2n minus 2 factorial plus 2 upon 2n minus 1 factorial plus 4 upon 2n factorial. Okay, I could have done this thing directly also without substituting t. For that I have to multiply by 2 here, and I have to write factors in terms of 2n, 2n minus 1, 2n minus 2. Then also you can get it. If you are comfortable directly with n, go with that method only. But if you think that this is better, so that is one idea I'm giving and I'm sharing with you. Now we have to find the summation of this where n is starting with 1 going till infinity. Okay, so I will be writing these values. If you put n is equal to 1 here, so this will be 0 factorial. Okay, so let me write the first term first. So it will be 1 upon 2, 1 upon 0 factorial, I can write it as 1, then 1 upon, if you put n is equal to 2, it will be 2 factorial. It will be 2 factorial. Only even terms will come here, and so on till infinity. Then for the other term, 2, if I write 2 outside, if I write 2 outside and put n is equal to 1, we will be starting with 1 upon 1 factorial, then 1 upon 3 factorial plus 1 upon 5 factorial, and so on. It will also go till infinity. Then the last thing, that 4 upon, so 4 outside, this will be 1 upon 2 factorial plus 1 upon 4 factorial plus 1 upon 6 factorial, and so on till infinity. Now dear students, as we all know the expansion of e power x, so using e power x, e power 1 will be 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial, and so on till infinite. If I write e power minus 1, it will be 1 minus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 this will be minus, not plus, yeah, minus 1 upon 3 factorial plus 1 upon 4 factorial minus, and so on till infinity. Now we have to add or subtract these two to get these terms here. If you add these two terms, I think you will be getting 2 times the same bracket which is written here. Okay, 1 plus 1 upon 2 factorial plus 1 upon 4 factorial, and so on. So this is actually 1 upon 2 into e plus e power minus 1 divided by 2 plus 2 times. This is nothing but if you take the difference of these two, you will get 2 times of this. So this will be e minus e power minus 1 upon 2 plus 4 outside. This is actually similar to this, only 1 is missing. So it is actually e plus e power minus 1 upon 2 minus 1 here. So let's collect all the terms of e. So this is 1 upon 4 here, this is 1 here, and this is 2 here. So 2 plus 1, 3, 3 plus 1 by 4. 3 plus 1 by 4 is how much? 3 plus 1 by 4 into e. Okay, and similarly for e power minus 1, it is minus 1 here and plus 2 here. So 2 minus 1, so plus 1, and this will be 1 plus 1 upon 4 e power minus 1, and then constant term, that is just minus 4. So this becomes 13e by 4. Is there any option? Yeah, 13e by 4 is there. 13e by 4. This will be 5e by 4 minus 4. So the answer of this question will be 13e by 4 plus 5e by 4 minus 4. So 2 is the answer of this question. Okay. Now you cannot do this question without writing like this, because there is no standard sequence where we can find summation of this. It is not AP, GP, AGP, which we can do directly. In fact, there are expansions which we have to use to know what exactly this series would be. Okay, coming to the next question. Here we are given C be the circumcenter of the triangle formed by these lines. Okay, so let me, yeah, so 4x plus 3y equal to 69, 4y minus 3x is equal to 17, and x plus 7y equal to 16, 1. Now here, if you try to find the circumcenter by knowing the vertex of the triangle, and then finding this equation of the circle, and then finding the center, can be a big task. But if you look at these two lines, this is L1, this is L2, this is L3. I think it is very much clear that L1 and L2 are perpendicular to each other, because slope here is minus 3 by 4, slope here is 3 by 4. In fact, coefficient of x and y are interchanged, and there is one minus sign also. That's a very common trick to write equation of a line that is perpendicular to given line. So these two lines are perpendicular. Now, if two lines are perpendicular, so this triangle formed by L1, L2, L3 has to be right triangle. And if it is a right triangle, its circle has to have this hypotenuse as a diameter, or you can say the midpoint of hypotenuse has to be has to be the center of this circle. So let me call this line as L1, this line as L2, and this line as L3. So what we need to do, we need to find these point of intersection of L1 with L3 and L2 with L3. This line is L2 and this line is L3. So L3 with L2 point of intersection is B, L1 and L3 point of intersection is A. These will be the diametric ends. So to know the center, we just need to find the midpoint of A and B. So now simple question, solve L1 with L3, solve L1 with L3 and then L2 with L3 and then midpoint formula, nothing else. Okay, so how we can do it? To solve L1 and L3, maybe I will like to multiply this by 4, L3 I will multiply by 4 and then I will subtract L1. So 4x will be cancelled and 7 into 4, 28 minus 3 is 25y. And on the right hand side, this will be 4, 244, yeah 244. Yeah, 244 minus 69. How much it is? I think it is 105 here, 7 here and 1 here. So the value of y is coming out to be 7. Yeah, correct, 7. Okay, now put y equal to 7 here. So we will be getting x is equal to 49 minus 61 minus 49, I think 12. Yeah. So L1 and L3, this point of their intersection is 12, 7. You can just check once again. 12 into 4, 48, 48 plus 21. Yeah, 69, that is correct. And 12 plus 49 is 61, that is correct. Now finding the point of intersection of L1, L2 with L3, L2 with L3. If we have to solve these, I think I will be multiplying this by 3 this time. I will multiply this by 3 this time. Okay. And I will add these two. So 3x will get cancelled. 21 plus 4, once again 25y we are getting. 21 plus 4, 25, and 3 into 61 is I think 183 and plus 17. Okay, so this becomes 200. So y will be equal to 8, and if you put y is equal to 8 here, 7 into 8 is 56. So the value of x will be I think 5. You can check this point B, point of intersection is 5, 8. Let me check once again. Is it, if it is satisfying L2, 5, 8. So 5, 8 into 4, 32. 32 minus 15 is 17. That is correct. And 5, 8, yeah, 61 is correct. Now we just have to find the midpoint, alpha, beta. This is midpoint of 12, 7 and 5, 8. So this will be 12 plus 5, 17 by is 7 plus 8 is 15 by 2. Okay. Now if we try to find this expression, alpha minus beta will be 17 minus 15 is I think 2 by 2. So 1 square is 1 only, plus alpha plus beta. 17 plus 15 is 32. 32 by 2 is 16. So 1 plus 16. So answer of this will be 17. That is 2. Okay. So this is how this question was to be done. Now coming to the next question. One more thing. This kind of question, I have one idea. Although for this question, I think that's the best method, no doubt about that. But there is one more thing, one more way of finding this equation of circumcircle using family of lines. Okay, how this can be done? Not family of lines, you can say family of circles also. If this is line L1, this is line L2, this is line L3, where I will be writing L1 as 4x plus 3y minus 69 equal to 0 and so on. So keep all the constant on the left hand side, make this as 0, then your circle can be written as L1 L2 plus lambda L2 L3 plus mu L3 L1 equal to 0. Now this equation, whatever it is, it will be satisfying all the 3 point of intersection taken in pair A, B, C dash maybe. Okay, because A will make L1 L2 0. So it will make L1 L2 0, so make this also 0, make this also 0. Similarly, all the points will be making all the terms 0, 0, 0. So whatever lambda mu you take, you will be getting this sum equation that is passing through all 3 A, B, C. Now, if this has to be a circle, when you are multiplying them, you will be getting 2-degree terms where coefficient of x square will be there, coefficient of y square will be there, coefficient of xy will be there. So in order this to be a circle, your coefficient of x square and y square should be equal, coefficient of xy should be 0. So by doing that thing, you can get lambda and mu, and then you will find the equation of circle. But here this will be a big calculation because these numbers may not be that good. But this question is actually meant by recognizing the fact that L1, L2 are perpendicular. If they were not perpendicular and you're not getting any idea, then I will go with this method. Okay. Coming to the next question. let the circle C touch the line x minus y plus 1 equal to 0 have the center on the positive x-axis and cut off a chord of length 4 upon root 13 along the line minus 3x plus 2y equal to 1. Let h be the hyperbola whose one of the foci is center C and length of transverse axis is diameter of C. Then 2 alpha square plus 3 beta square is what we need to find. So please see what they are asking. First of all, you are given a line whose x-intercept is minus 1 and y-intercept is 1. So this line will be something like this. Okay, now there is a circle that touches this line whose center lies on positive x-axis. So your circle should be something like this. Okay, and its center will be alpha comma 0. I think alpha they have used, so I will use p comma 0 actually. I will be using p comma 0 here. So center is p comma 0, p has to be positive. Now the line, now if you draw perpendicular from this point to this line, this will be equal to the radius of the circle. So we can write equation, we can use this equation and we can write the radius of the circle directly. R will be, put p here, we get p plus 1 upon root 2. In fact, p is positive, so p plus 1 has to be positive, so radius will be this. There is no need to put mod on this to get this perpendicular distance. Now, one more diagram I will make, and the diagram is this circle I have made once again, and they are saying this circle cut a chord of length 4 upon root 13 along this line minus 3x plus 2y equal to 1 or minus 1 equal to 0. So if it is so, that means your diagram is that if from center, that is p comma 0, if this is the perpendicular distance d, okay, and because it is cutting the intercept of 4 upon root 13, so it should be 2 upon root 13 this side and it should be 2 upon root 13 this side, and that will be equal to radius r. Now here we can find d as, put this p comma 0 in this, we will be getting minus 3p minus 1. So if you put mod, it will become 3p plus 1 whole divided by root 13. Okay, now we can apply Pythagoras theorem to get a relation between p, because r is in terms of p, d is in terms of p, and this is 2 root 13. Okay, let me do it on the next slide. So what I should be getting, I should be getting d square plus 2 upon root 13 whole square, and that will be equal to radius square. Okay, and we got d to be 3p plus 1, yeah, 3p plus 1 upon root 13 whole square plus 4 upon 13, and r was p plus 1 by root 2, p plus 1 whole square upon 2 we can say. So this becomes equal to, I think, 9p square plus 6p plus 1 plus 4 whole divided by 13, and that will be equal to p square plus 2p plus 1 whole divided by 2. Multiply 2 this side, so it will become 18p square plus 12p plus 10. 4 plus 1, 5 into 2, 10 is equal to 13p square plus 26p plus 13. So this will be 5p square this side. 26 if I take on that side, it will be minus 14p. Okay, and minus 3 equal to 0. Okay, so I can split minus 14 as minus 15 plus 1. So one of the factor will be p minus 3 and other factor will be 5p plus 1. You can multiply them to check it is correct or not. 5p square minus 14p, correct, and minus 3. So we are getting p to be equal to 3. So if p is 3, your radius will be p plus 1, so 4 upon root 2, that is 2 root 2. So the radius is 2 root 2. Now let us see what else we need to do. So we are given center C. C is p comma 0. C is 3 comma 0. That is the focus of the hyperbola. And also they have given length of transverse axis is the diameter of C. So length of transverse axis is 2 alpha. It is not alpha, please be careful. Length of transverse axis is 2 alpha. So 2 alpha is equal to diameter. So alpha will be equal to radius, that is 2 root 2. Okay, and so we will be getting alpha into E, because focus is at AE. A is alpha here, so AE is 3, alpha is 2 root 2, so eccentricity is coming out to be 3 upon 2 root 2 for the hyperbola. Okay, now we know everything. Now we can find 2 alpha square plus 3 beta square. 2 alpha square, alpha we already know, plus 3 beta square. Okay, so this will be equal to 2 alpha square plus 3 alpha square into E square minus 1. Okay, just put these values. I think I can say 2 alpha square minus 3 alpha square is minus alpha square. So minus alpha square means minus 8, and this will be plus 3 into alpha square is 8, and e square is 9 by 8. So this 8 will be cancelled. So we are getting 9 into 3, 27. 27 minus 8 is 19. So answer of this question should be 19. Yeah, 19 should be the answer of this question. Okay, this question was not difficult, I will say, but it was lengthy because you have to find the equation of circle, not equation, center and radius, and then using that information you have to find E transverse axis, and then you have to use the relation between transverse axis, conjugate axis and E to find this value. Okay, coming to the next question. Here we are given Z1 and Z2, two complex numbers such that Z1 plus Z2 is equal to 5 and sum of their cube is 20 plus 15 iota. Okay, and then we have to find the mod of Z1 power 4 plus Z2 power 4. I think this is simple question. Just keep putting these identities and you will get the answer. Here I can write this 20 plus 15 iota, that is Z1 cube plus Z2 cube, and we can write this as Z1 plus Z2 whole cube, that is 5 whole cube. Okay, minus 3 times Z1 Z2 into Z1 plus Z2, that is 5. Okay, so this will become 125. So we can find Z1 Z2 from here. I think I will bring this side, so 15. So this is 125 minus 20, so it will be 105 minus 15 iota upon 15. Yeah, so that will be equal to 7 minus iota. So this is one thing we have got. Sum of roots or sum of Z1 Z2 we already know, and product of Z1 Z2 also now we know. Now we have to find Z1 power 4 plus Z2 power 4. So one of the idea could be you write this as Z1 power 3 plus Z2 power 3 multiplied with Z1 plus Z2, and then you have to subtract minus Z1 Z2 into Z1 square plus Z2 square. Okay, now in this case you need to find Z1 square Z2 square also. I think that is very easy to find. Z1 square plus Z2 square is nothing but Z1 plus Z2 whole square minus 2 times Z1 Z2, that is 7 minus iota. So this will be 25 minus 14. So I think 11 here and plus 2 iota. Yeah, correct. Now let's put all these values here. This is nothing but 20 plus 15 iota, and Z1 plus Z2 is 5 minus Z1 Z2 is 7 minus iota. Z1 square plus Z2 square is 11 plus 2 iota. Okay, so what will be the real part? I think 100 from here, 7 into 11, so minus 77 from here, and this 2 iota with minus iota will become 2. There is minus 1 also, so minus 2 here, minus minus plus, yeah, minus 2, correct, plus imaginary part, I think 75 from here, and this will be minus 11, actually plus 11, because this 11 into minus iota, 1 iota minus sign outside also, and then it is plus 14, I think, into iota. So what is final thing we are getting? This will be 23 minus 2, so 21 plus this will be 14 plus 11 is 25 plus 100 iota. 100 iota, 1 minute. 15 into 5 is 75, and this will be 11 iota with minus minus plus, and that will be actually minus sign here, not plus sign here. Yeah, this will be minus sign here. Okay, so if you subtract, so from 75 we have to subtract 3, so 72 it would be 72. Okay, so we need to find the mod of this thing. So mod of Z1 power 4 plus Z2 power 4, this is Z1 power 4 plus Z2 power 4. I think I can take 3 outside because from 21 and 72 3 is common, then 7 square plus 24 square, and they are Pythagorean triplets, 7, 24 and 25. So this becomes equal to 75. So option A should be the answer of this question. Okay, see, I have tried this question by other methods also, like Newton's identities. I think more or less calculation is similar, so this one is better. You can try with other methods also. You can transform your equation because you know the quadratic sum of roots, product of roots, but because your coefficients are in terms of iota, you have to do the calculation. You cannot escape that. Okay, now coming to question number 10, one very interesting question of limits. In this question they are asking, as n tending to infinity, what will be the product of these terms? Okay, now when this question came, in that year I remember we were discussing how which form it is, but if you look at it very closely you will find one very interesting thing here. For example, if I find this value here, it will be 1.414, that is 2 power 1 by 2, and root 2 will be also bigger than 1, maybe 1.2 or 1.3, doesn't matter actually. So the value will be less than 1, in fact very close to 0.1 or 0.2. Okay, I can say 0.1, 0.2. Now here also, if you look at this value, this will be slightly bigger value, because 2 power 1 by 5 will be closer to 1, maybe it will be 1.07 or something like that. So this value will be little bit bigger, but still it will be less than 1. You can say it will be 0.36 or something like that. Even the last value, if you look at, this will be 1.414 minus 1, because 2 power 0 it will tend to, so it will be 1, so this is 0.414. Okay, now so the biggest term among all these terms is 0.414, and all these terms are less than 1. So as you keep increasing the terms, if you tend your n towards infinity, all the terms are less than 1, in fact less than 0.414. So if you multiply such terms infinite times, I think this has to give you limit tending to 0. So answer of this question has to be D, nothing else. Very simple question. Now I can say one thing, this will be less than or equal to, because this is the last term, this is the biggest term, that is the last term, you can say it will less than or equal to 0.414 raised to the power n. Replace all terms by the last biggest term 0.414, then also you can see this will be tending to 0. So using sandwich rule or whatever you say, this limit has to be 0 only, nothing else. So simple question, 0. So dear students, I am sharing with you the link to join Eklavya JEE Mains test series and Eklavya Telegram channel. Please join them as soon as possible. Coming to the question of statistics. Here we are given x as 11, 12, 13, 40, 41 and y as 61, 62, 63 and so on. Be two sets of observation if x bar and y bar are their respective means, and sigma square is variance of all observation in x union y, then we have to find this. Okay, so what we will do, dear student, in this, first of all we should understand x bar is found directly, because all these terms are forming AP. So the AM of this sequence is nothing but AM of first and last term. So 11 plus 41, 52 divided by 2, so 26. You can find the sum of all the terms and divide by number of terms. That way also you can do, not a very difficult task. In fact, total number of terms starting with 11 going till 41, I think total number of terms will be 31. So you can do this way also, number of terms 31 by 2 into A plus L, that is 11 plus 41, and divided by number of terms 31. So you can see it is coming out to be 26. Same thing. Now similarly we can find y bar also. It will be sum of first and last term divided by 2. In fact, every term of y, you can see if you compare with the corresponding term of x, the sum the term is 50 more than that, 50 more than that, 50 more than that. So this mean x y bar as compared to x bar should be 50 more, that is 76. So we have found this, we have found this. Now we have to find sigma square. Now how to find sigma square? So what I will do, we know x bar, we know y bar, and both the data set are having equal number of datas. So you can find the combined mean. If I find the combined mean x bar, that will be this plus this divided by 2. I think 26 plus 27, that is 102 by 2, so 51. Okay, now we know the property that if every data is subtracted or added by a constant value, then variance doesn't change. So what I will do, I will take x union y, okay, and then I will subtract each data by 51. You may call x dash y dash, each data subtracted by 51. So this will be minus 40, minus 39 and so on. That will be minus 10. And here if you subtract 51, it will start with 10 and then 11 and so on. It will be ending at I think 39 and then 40. 91 minus 51 is 40. So you can see this data for which variance we are going to find is this thing, and very easily it can be seen that sum of all the data is 0. So average or mean of this will be 0 after subtracting 51 from it. Okay, so the new x bar dash you can say will be 0. Now I will be using that formula of variance, that sigma square is equal to 1 upon n summation of x square minus sigma x upon n whole square. Okay, this is dash here, this is dash here. Dash I am using for the data which I have obtained after subtracting 51 from it. Now this is already 0. In fact, we made it 0 so that this term we don't have to take care of. Now you can see 1 upon n will be, I think total data was 31 here, 31 here, so 62 here, and summation xi square. So if you look at these numbers, I think they are 10 square plus 11 square up to 40 square 2 times, because with minus sign also sum of square will be same thing. So it becomes 10 square plus 11 square plus 12 square up to, I think it is 40 square. Let me check once again. 40 square, yeah, starting with 10 going till 40 square. Now how we will do it? It will be 1 upon 62 into summation of square of first n natural number I will be using and appending 1 square, 2 square, 3 square up to 9 square here. So this will become 40 into 41 into 81 divided by 6, n into n plus 1 into 2n plus 1 by 6 minus the sum of square of first 9 numbers, that is 9 into 10 into 19 upon 6. Now let's try to solve it. 1 upon 62, and one more thing, I think here we have to multiply with 2 also. We have to multiply with 2 also because same square will be obtained twice, one with positive data set, one with negative data set. So into 2 also we have to do. Okay, so into 2 also we have to do. Now we can take, I think 9 into 10, 90 upon 6, 15. I can take common. So I will be taking 9 from here and 10 from here. Upon 6 becomes 15. So if I take 10 from here, so it will be 4 into 41 into 9 here, and minus if this is taken, so 19 only. Okay, so this is 1 upon 31. 15 into how much will it be? 41 into 36 minus 19. Okay, so how to do it? Maybe 164 into 9 minus 19. Let me do the calculation separately. 164 into 9. So 9 into 4 is 36, 9 into 6 is 54, 54, 57, and 9 plus 5 is this 1476. Yeah, 1476, and I have to subtract 19 from it, so we will be getting 1457. Okay, and this 31, if you divide it, I think you will be getting, let me see if 31 divides it or not. I think it should divide in order to get a good answer. So 31 into 4, 124, so 217, 7 times. Yeah, 217 is correct. So 47 into, so we will be getting 47 into 15 is also multiplied outside. So the variance is coming out to be 15 into 47, that is 705, I think. Yeah, 705. And what we are looking for? We are looking for x bar, that was 26, y bar 76 minus 705, 705 a mod. So that is 102 minus this, so 603 is the answer of this question. Okay. See, there has been many questions where they are combining two data sets from different sets, or maybe same set they are adding or multiplying with some other number. So modification of a data by one way or the other, that is one very favorite thing of paper setter, I will say. So please go through such questions. This is, I will say, one very important question for your upcoming exam. Now this question, I really like this question very much. I will tell you one line answer of this question first, and then I'll tell you a bigger method also, obviously. And why I'm saying obviously, because their intended solution will be the bigger one only. So here you can see a into some x, or maybe x1, you are getting 2 into x1. A into x2 equal to 4 into x2, same matrix we are getting it here. A into x3, we are getting 2 into x3, same x3 here. So if you know the concept of eigenvalue, eigenvector, so we have found 3 eigenvalues of A as 2, 4 and 2. Eigenvectors are different for first one and the last one. So 2, although same eigenvalues, they will be counted repeated because different eigenvectors are giving you 2 values. So this has to be 2 times. Now, if A is a 3 into 3 matrix, which it has to be, it is given in the question also, it will be having its characteristic equation as a cubic. We know A minus lambda I, or A minus lambda I equal to 0 is the characteristic equation of A, which is a cubic, and its roots are already known, 2, 4 and 2. So this will have roots as 2, as 4 and 2 only. That means A minus 3i cannot be 0, because if A minus 3i is 0, then 3 will also be an eigenvalue. Why I am saying A minus 3i? Because in this equation they have given A minus 3i as a coefficient matrix for this system of linear equation. Now if its determinant is not equal to 0, that means it has to have a unique solution, no other option, direct question. Okay, now this we could do because these x1, x1, x2, x2, they were same. But I have seen one more question of JEE Mains where they have taken these two different column matrix. these two different, these two different. In one of them, I think one of them was same. But what will be the general method if, what will be the general method if these metrics are not same? So what we can do, we will be writing A into the first column matrix 1 0 1 as a first column here, then minus 1 0 1 as a second column, and then 0 1 0 as a third column, and that will be equal to, here you will be getting 2 0 2, here you will be getting minus 4 0 4, and here it will be 0 2 0. Now dear students, you can find the inverse of it. You can multiply on the right side, you will get A. That can be one method. Or you may take A as, let's say, A B C D E F G H I. Okay, now if you take A like this and if you multiply this column, this first row with the last column, okay, A B C multiplied with this, I think it will be just B, and it should be equal to 0. The first row of A, last column of this will give you this 1 3 element, so we can see this B will be equal to 0. Similarly, if you multiply second row with the last column, your value of E can be found, because this will be E and this will be compared with 2, so E will be 2. Similarly, H will be equal to 0. So you have found this column directly. Now similar multiplication if you carry out, we will be able to find A C D F G I also. That way also you can find A and then A minus 3i, and you will be able to know whether it is having no solution, infinite solution, unique solution, etc. But I'm sure you have understood that eigenvalue, eigenvector thing was very, very fast. If you know that concept, nothing like that. Dear student, this eigenvalue, eigenvector thing, I have done one session on that also. You may like that session. You may just search and you will go through, you can go through it. I have seen in JEE Mains and JEE Advanced, although this eigenvalue, eigenvector characteristic equation, they're not directly in the syllabus, but there has been immense use of that concept in these questions when it comes to do it faster. So please go through that thing once. Now this is also one interesting question. We are given A as 2 3 0 1, then we have to find determinant of A power 4 plus determinant of A power 10 minus adjoint of 2A whole power 10. I think determinant of A power 10 can be found directly. It will be just determinant of A power 4. This is nothing but 2 minus 2 power 4. So this will be 16. But what about this? How to find it? So dear student, there is no such theory that you can write this as determinant of A power 10 minus determinant of adjoint of 2A power 10 and some other terms. There is no such theory. So I was also wondering how they are asking this thing, and A power 10 will be a multiplication taken 10 times. That is also not an easy task. So either you get some shortcut, you get some pattern in A power 10, otherwise it is not possible to do. So what pattern we are getting here, please see. If you find A to A square, so it will become 2 square here and 0 here. 2 into 3, 6, 6 minus 3, so 3 here, and 0 plus 1, so 1 here. Similarly, if we find A cube, you can check it will be 2 cube here and 0 here, and some other term P here, Q here. I will not bother about it. Okay, but one thing is very clear. One thing is very clear that A power 10, if you find, your first column will be 2 power 10, 0, and some P10 and Q10 you can say. Now, what is 2A and what is adjoint of 2A? Adjoint of 2A means adjoint of matrix of 4 6 0 minus 2. This has to be when you are taking adjoint of 2 into 2, there is a direct method. In fact, you can take cofactor also of individual terms. So I think for 4 it will be minus 2 here, and 4 will go here, and minus 6 here and 0 here. Now we have seen a pattern in A to A square to A cube. Now if you look at adjoint of 2A, what you will find that here also there will be a pattern that adjoint of 2A whole power 10, if you do, your first column will again be minus 2 power 10, so 2 power 10 and 0 here, and maybe R10 here and S10 here. Okay, so we are not finding R10, S10, P10, Q10 here, but if they're asking determinant of A10 minus this thing, that means this minus this, if we do, I think you can see your first column elements will be cancelled. We will be getting 0 0, so A10 minus adjoint of 2A whole power 10 will be equal to 0 0 and whatever elements here, I am not bothered. Now determinant of this, if you're looking for determinant, I am mentioning it, so it will be 0. So what will be the answer? I think we got 16 for it, 0 for it, so answer will be 16 of this question. Okay, now without observing that pattern, it is not, I will say, possible to find the determinant. Okay, in fact that pattern was not there. I am not sure whether this kind of question can be solved or not. It can be solved, but it will take lot time because a power 10 will take too much time. See, there are not always patterns. Sometimes if or maybe pattern you cannot observe, but whenever they give questions based on higher power of matrix, it is most of the time based on patterns. Okay, sometimes this pattern can be derived or found using characteristic equation also. So but pattern has to be there, then only you can do this kind of question. Coming to question number 14, R is the smallest equivalent relation on set 1, 2, 3, 4 such that 1, 2 and 1, 3 belongs to a subset of R. The number of elements in R is the smallest equivalent set. Dear student, I will tell you two things. First, this kind of questions are very common. You have to find what element has to be there, what element should not be there, or if you're looking for smallest, then you have to choose each and every ordered pair only if it is needed, otherwise don't choose it. Then you can find the smallest equivalent equivalent relation actually. Another thing is that there is a concept of equivalent class within equivalent relation. What is that? In equivalent class, what we find that certain elements within that equivalent relation are connected with themselves, but if there is one more class within that set, these element will not be connected to the other element set. Let me give you the example without doing this question first. So suppose you are having set of let's say triangles delta 1, delta 2, delta 3 and so on, and these triangles are having ratio of sides as 1 4:3:5. All these triangles, this first row delta 1, delta 2, delta 3 and so on, they are having ratio of their sides in the ratio of their sides in 4:3:5. Now one more delta, I am taking delta 1 dash, delta 2 dash, delta 3 dash. These triangles are having sides in the ratio of let's say 5, 12 and 13. Okay, 5, 12 and 13. Now there is a relation which says if two triangles are similar, then they are related. Then definitely this kind of relation is equivalent. Now in this delta 1, delta 2, delta 3 and so on, they will be related to they all will be related to each other. Delta 1 will be related to delta 1, delta 1 will be related to delta 2, delta 3 and so on. But they will not be related to any of the triangle in this delta 1 dash, delta 2 dash, delta 3 dash. Similarly, this also will be related to themselves but not related to the earlier one. So what you can see, there has been created, there has been a class within this set where one class people or one class elements are related to themselves and they are not related to other, and similarly for the other class. So here why I am taking this example, and that is a characteristic thing of equivalent relation, that all the elements, they create classes. Sometimes there can be just one class, that means all the elements will be related to themselves. Okay, but if there are classes, then one class will not talk to the other class, you can say that way. Okay, now here because we are given 1, 2 and 1, 3 ordered pair is there, 1, 2, 1, 3 ordered pair is there, that means if this is there in that equivalent relation, so the smallest equivalent relation that I can find is when I just connect 1, 2 and 3 with themselves and I ignore 4. Okay, but one more thing, when we are writing equivalent relation, then it has to be reflexive. So 1, 1, 2, 2, 3, 3 and 4, 4 has to be there. You cannot ignore 4, 4 because on this set 4, 4 has to be there. But when we are making this as a equivalent relation where 1, 2, 1, 3 is there, I will write 1, 2, then I have to write 2, 1 so that it becomes symmetric. Then I will be writing 1, 3, I will be writing 3, 1 also so that it becomes symmetric. Then this 2, 1, 1, 3, I will need 2, 3 so that it becomes transitive, and then I need 3, 2 also. Now you can check among 1, 2 and 3, all possible ordered pairs are written. 1, 1, 2, 2, 3, 3 was already written, and now 1, 2, 2, 1, 1, 3, 3, 1 all are written. Now you can check, this is equivalent relation. 4 we have ignored. You can think of 4 was having separate equivalent class and it was not related to any other element, and in order this to be smallest equivalent relation, I think we will do it intentionally. If you make even one of the ordered pair of 4 with 1 or 2, you will have to write all other ordered pairs also. So in this smallest equivalent relation will be when we are connecting all 1, 2 and 3 with themselves, but 4 we are keeping it separate. Okay, so this will be the smallest equivalent relation. I hope that is clear. So how many element it is having? I think it is having 10. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I remember this answer. So answer is 10 here. Okay. Coming coming to this question, one very interesting question, dear student. F R to R is a function defined by this relation x minus 3 power n1, x minus 5 power n2, n1, n2 belongs to natural number. Then which of the following is not true? Okay. Now this question I took intentionally because I have seen student doing this question by AOD. In fact, this question is supposed to be of AOD because they're asking maxima, minima, local maxima, local minima. But I will tell you another way in which you will be able to solve it directly. Please see the first part, A part. First of all, we are having only two roots. The one is 3 and one is 5. Okay. For A option, the power of x minus 3 is 3 and power of n2, power of x minus 5 is 4. So that means if you use wavy curve method, your sign on this number line will be like this. At 5, sign will not change because it is even number, and at 3, sign will change. Now if we try to draw the graph, okay, now please see, at x is equal to 3, your root is repeated 3 times. Root is repeated 3 times. That means your graph will be coming like this, touching the graph, because repetition is 3 times, but because sign is changing, it has to go like this. At 5, repetition of root is 4. That means the graph will be again touching at 5, but sign is not changing, so it will go like this. And it is continuous function, so your graph will be like this. Maybe some changes can be there because it is not accurate graph, but one thing is very clear, it will have a local maxima point between 3 and 5, which they are also saying there exists alpha between 3 to 5 where f attains local maxima. So this is true. So this is not my answer. This is true, this is not my answer. One thing I would like to tell you, because some of you may be thinking that why graph will be like this, why not other roots can be there. So please listen carefully. When fx is having x minus 3 root repeated 3 times, x minus 5 root repeated 4 times, and if you differentiate it in its derivative f dash x, 3 will be repeated 2 times. 3 will be repeated 2 times. Why I am saying so? Because in fx it is repeated 3 times. So if it's if you take the differentiation, it will be repeated 2 times. And f dash x, this 5 will be repeated 3 times. Why I am saying 3 times? Because it was 4 times repeated in fx, so it will be 3 times repeated in f dash x. Just one time your repetition reduces when you do the differentiation. So total number of roots you have identified so far is 5. Okay, and by Rolle's theorem, between 3 and 5 there has to be one root, and that will be different from 3 and 5. So we have got one more root here, let's say alpha. So 2 plus 3 5, 5 plus 1 6. 6 root we have identified, and you can see this was 3 plus 4 7 degree. So we have found all these 6 roots, because differentiation of 7 degree polynomial has to be 6 degree, and we have found all 6 roots. So this is the possible graph, nothing else is possible. So this will have maxima between 3 and 5. Okay, so that is one A part. Similarly, I'll do for B part here. Now I'll do it fast. 3 and 5. For B part, both this is 4, so this will be plus here, this will be minus, this will be plus here. In this case, graph will come from infinity, will go like this, and negative, and this time it will be going like this and like this. Okay, positive, negative, positive. At 3, the repeated root is repeated 4 times. 1 minute. Okay, sorry, I did a mistake here. Yeah, the mistake is this will be minus, not plus, because n1 is 4, so sign will not change here. So the graph should be coming like this, and it will be going like this. Okay, so you can see between 3 and 5 there is a point of local minima. I think spelling is something not correct, but this is also true. This is also true. This was also true. Now this way, if you keep doing it, let me do C part also. 3 and 5. In this case, both are odd. So plus, minus, and plus. And so this will be going like this, positive, negative, and positive, like this. The total order is 8. Yeah, so it will be coming from plus infinity going to plus infinity, and between 3 and 5 it will be having local minima. They are saying local maxima, so this is false. So that is my answer. I will leave this D part for you to analyze. I think D is also true, so answer correct with C only. Okay, coming to the next question. Okay, bachcho, before I go to the next question, these are the QR code of JEE Mains test series and Eklavya Telegram channel. Do join it as soon as possible. Now coming to this question number 16, we are given indefinite integration. See, this question I have taken intentionally because although this is not very difficult question, but I've seen this kind of question being asked in mains many times. In fact, in advanced also I've seen this question 1 or 2 times. So dear student, what is the important thing here is that you are given linear, power 4, power 6 and whole power 1 upon 5. So in effect, if you take the sum of powers of these two linear terms, they are 4 upon 5 plus 6 upon 5, that is 2. So whenever your power sum in denominator of linear factors, two linear factors is 2, there is just one way, no other method. And what is that method? Please understand it. I can write it as x minus 1 upon x plus 3 whole raised to the power 4 upon 5, and then it will be x plus 3 power 2 dx. You can check x plus 3 power 10 I have taken outside, and because 1 by 5 was there, so x plus 3 power 2 will be there, and if you are taking 10 there, so 6 was already there, so upon 4 you have to do here. So x minus 1 upon x plus 3 whole power 4, and that 1 upon 5 is also there, so this is your integral now. Now you can see x minus 1 upon x plus 3, which I can write it as x plus 3 minus 4 upon x plus 3, so that is 1 minus 4 upon x plus 3. So the derivative of this, will be d of x minus 1 upon x plus 3 will be equal to, with respect to x, if you do, it will be 4 upon x plus 3 whole square. Okay, so if I take this as t, so I'll be getting dt is equal to 4 dx upon x plus 3 whole square. Okay, so just put this here, so we will be getting 4, actually 1 upon 4, not 4, because 4 I need and 4 is not there, so I have to divide by 4. So we will be getting dx upon x plus 3 whole square as 1 upon 4 outside, dt upon t power 4 upon 5. Then it is done. I think t power 1 upon 5 upon 1 upon 5, so 5 upon 4 it will become plus c. Okay, now I think it is very clearly seen that this t, which I took x minus 1 upon x plus 3, so comparing will give you alpha is equal to 1 and beta also equal to 1. Okay, and this value of a, is 5 by 4, and the value of b is I think 1 upon 5. So what will be alpha plus beta? 2, and a, b will be 1 upon 4. 1 upon 4 upon 20 is how much? 5. I think 7 will be the answer. Let me just check once again. 1 plus 1 plus 20 by 4. 20 by 4, so 5 plus, yes, 7 is correct. So 7 is the answer of this question. Dear student, whenever sum is 2, please remember it. You have to do this way, no other way. Okay. Now this question of definite integration, I m comma n is given 0 to 1, x power m minus 1, 1 minus x power n minus 1 for m n greater than or equal to 1. And then this is also alpha into I m n, then we have to find the alpha. Now dear student, this question is based on substitution. We have to do 2 substitutions, and then we have to compare these 2 integrals. So for first one, I m comma n, I will just write I. So I am putting x as sine square theta. So this limit will be from 0 to pi by 4. So this will become sine power 2m minus 2 theta. This will become cos 2n minus 2 theta into 2 sine theta into cos theta d theta. Okay, so this becomes equal to 2 outside. This is 0 to pi by 2. 0 to pi by 2, and sine raised to the power 2m minus 1 theta cos 2n minus 1 theta d theta. Now if I apply King's rule, then this will become 0 to pi by 2. Okay, sine will become cos and cos will become sine. And from this, if you add, you get 2i is equal to 2 times 0 to pi by 2, and sum of these two, sine power 2m minus 1, cos power 2n minus 1 plus cos power 2m minus 1 sine power 2n minus 1 d theta. Now if you again apply King's rule, that nothing will change. So you can write this as 2 common outside, 0 to pi by 4, and that is sine 2m minus 1 cos 2n minus 1 plus cos 2m minus 1 sine 2n minus 1 into d theta. So my I is coming like this, 0 to pi by 4, and this is the function of integration. Now let us do one thing for another form, that is alpha into I m n. I will be putting here x is equal to tan square theta. If you put x is equal to tan square theta, your limit will become 0 to pi by 4 into, this will be tan power 2m minus 2 theta plus tan of 2n minus 2 theta. Tan power 2m minus 2 plus tan power 2n minus 2, and in the denominator this will be secant square theta whole power m plus n into dx will be 2 tan theta into secant square theta d theta. Okay, so this secant square theta, if you take in the numerator, it will become, I think, cos square rather cos power 2m plus 2n, and one this cos square secant square will reduce the power of cos by 2. So this will effectively be 0 to pi by 4. Let me write this as cos power 2m plus 2n minus 2. Okay, and let me bring this 2 outside, this 2, and 10 multiplied with this will give you 10 2m minus 1 plus 10 power 2n minus 1 d theta. So this is what we are getting for this alpha I. Okay, now if I multiply this cos with 10, I think we will be getting sine power 2m minus 1 into cos power 2n minus 1. Similarly, this 10 when multiplied with this will give you sine 2n minus 1 into cos 2m minus 1. So exactly same thing what we are getting. So 2 into I we are getting, not 2 into I actually, because I was 2 into this thing. So it is just, I think, I only. Let me just check once. Yeah, so the alpha value will be equal to 1 here. So the value of alpha here will be 1 only. Okay. Now coming to this question of 2023, it says let the area enclosed by the lines x plus y is equal to 2, y is equal to 0, and the curve fx is equal to minimum of this thing, where bracket x denotes greatest integer less than or equal to x, then we have to find 12a. Okay, so here in this question, the first thing that we should do it is to make the diagram. Okay, because how you will be come to know where this will be, which function will be minimum for which x. So if I look at these two functions, so one of them is x square plus 3 by 4, so it will be upward parabola, value at 0 will be 3 by 4. Okay, and the other function is 1 plus greatest integer x. Now this 1 plus greatest integer x means between 0 to 1, between 0 to 1 the value will be 1 always. So that means it should be something like this. Actually at 1 by 2 it will intersect. So your function, the graph will be like this. At 1 by 2 you can check the value of x square plus 3 by 4 is 1, and this greatest integer function is taking the value, of 1 entirely between when x is from 0 to 1. Okay, at 1 the value of greatest integer function will become 2. Okay, and then it will go like this. Okay, this point will be if you equate this is equal to 2, I think that will become pi by root pi by 2 actually. Root pi by 2 will be the point of intersection of this graph of greatest integer with this parabolic graph. So if we are looking for minimum of this, so minimum, and also let me check what area we are looking for. Area we are looking for is bounded by x plus y equal to 2. X plus y equal to 2 means it should be passing through 2, 0, passing through 1, 1, and like this. And y equal to 0 and x is equal to 0, that means x axis, y axis, that is in the first quadrant. Okay, now for this portion, the minimum of this function will be from 0 to 1 by 2 given by this parabola, and then it will be given by this greatest integer function. So basically we are looking for this area. So you can see this is almost I will say trapezium, if we ignore this part. So what I will do, I will find the area of trapezium and I will subtract this portion. Now how this is to be found, please understand this point is 1 by 2 comma 1. Okay, so let me first find this area which we have to subtract from that trapezium. Okay, I think that you can see. So here this is the portion bounded with vertex of the parabola axis. Okay, and double ordinate, or one portion of double ordinate you can say. So this area is always 2/3 of the area of rectangle. And which rectangle I'm talking about? I'm talking about this rectangle. I think this diagram is a bit small, but I hope this can be seen. Now this rectangle will have width, because this point is 1, this is 3 by 4, so 1 by 4 this height, and this width is 1 by 2, so this will become equal to, I think, 1 upon 12. 1 upon 12 is right. Okay, now the area of trapezium, let me call this as a dash, will be equal to 1 by 2 into sum of parallel sides. Sum of parallel side means it will be going from this to this. So this is 1 here, and the other parallel side is 2 into perpendicular distance between these two sides, and that is nothing but 1 here. So we are getting this to be 3 by 2. So the net area that we are looking for is T by 2 minus this area that was very small area bounded with, parabola and this line. So that was 1 by 12. If I take 12 as LCM, so 17 by 12 we are getting. I think 3 into 6, 18. 18 minus 1, 17 by 12. So 12A, if we are looking for, it has to be 17. Okay, now here I didn't need to do any integration if you know this thing of 2/3. Okay, now I think I have done several overwriting, but I think you understand which area we have found. I think x-axis, y-axis, then this parabola, then greatest integer, and this x plus y equal to 2. So this is the area we have found, and for that I found area of trapezium, and then we subtracted the area, small portion of area that is bounded between parabola, its axis, and one side of double ordinate, you can see. So this is the answer 17 for this question. Okay, moving to the next question. This one is really very nice question from 2022. F is a differentiable function satisfying fx is equal to 2 upon root 3 into integration and x greater than 0 and f1 is root 3. We have to find if y equal to fx pass through the fixed point alpha comma 6, then what will be the value of alpha. So for that, first we need to find, we need to solve for this function. So to solve this function, what I will do, I will first do a substitution, lambda square x upon 3, I will take as t. Okay, if I do this thing, my x will be equal to lambda square. It was there, that's correct. Not x, sorry, 1 minute. So my lambda will be, because the integration variable is lambda, not x. So lambda will be equal to root over 3 upon x into root 3. This lambda will be equal to root 3 upon x into root 3. Now, if I put these values, so fx will become equal to 2 upon root 3, and this limit for 0, it will be 0 only. But when lambda is equal to root 3, so this 3 will get cancelled, t will be equal to x here. And then this is f of, I think I have taken this entire thing as t, so this will be ft here into d lambda. So this is lambda, so what will be d lambda? It will be root 3 upon x into 1 upon 2 root t into dt. Okay, now we have to solve it, and we can see this 2 upon root 3 and this root 3 and 2 is getting cancelled. So we are getting here, I think 1 upon root x also I can bring outside, 1 upon root x, 0 to x, and this will be ft upon root t dt. Ft upon root t dt, root x has come outside. Okay, now to solve it further, let me go to the next slide. Yeah, so I can write this as root x into fx is equal to 0 to t ft upon root t dt. Let me check once. Yeah, so root x multiplied with this will give you root x into fx. On the right hand side, it is 0 to x ft upon root t and dt. Now, if we do the differentiation here, it will become root x into f dash x plus 1 upon 2 root x into fx, and that will be equal to this limit was not t, it was x actually. So this becomes fx upon root x. Now these two things, if I take that side and call fx as y, okay, we will be getting root x into dy by dx, and that is equal to y upon 2 root x. Let me check once again. This will be y upon root x. This is going that side. After subtraction, y upon 2 root x is correct. Okay, so what we are getting 2 dy upon y is equal to dx upon x. Very simple differential equation. Solving it, we will be getting ln y square is equal to ln x plus ln c. So y square is equal to x plus c. X into c. X into c. Also, we were given x positive. Okay, so if x is positive, there is no need to put any mod here. It will be log x ln x directly. Now they have given f1 is equal to root 3. So if f1 is root 3, so y square will be 3 x1. So the value of c is coming out to be 3. Okay, so we have got the function. Now they are asking that if this function pass through alpha comma 6. So alpha comma 6 means y will be 6, so 36, and x will be alpha and c is 3. So solving it, we will be getting alpha is equal to 12 is the answer of this question. Okay, so the alpha value is 12 for this question. Done. Okay, coming to the next question. Here we are given a point P be the image of point Q in this line and R be the point 2, 5, -1. The area of the triangle PQR is lambda, and lambda square is equal to 14k, then we have to find the value of k. Okay, now please see in this question, we are given a line, we are given a point Q, So 3 comma minus 3 comma 1, and this P point is alpha comma beta comma gamma, that is the image of this Q in this line, and R is a point 2 comma 5 comma minus 1. Now there is one important thing. They have not mentioned whether R lies on this line or not, but if you put this coordinate 2 comma 5 comma minus 1, I think 2 upon 1 2, 5 minus 3 2 upon 1 also 2, minus 1 minus 1, so minus 2 upon minus 1 is also 2. That means this point is actually lying on this line 2 comma 5 comma minus 1. Okay, and then they are asking the area of the triangle PQR. Triangle of PQR they are asking. Okay, and if they are image, this P is image of Q, these two should be equal and this angle should be 90 degree. Now, if we are looking for the area, of this entire triangle PQR, I think required triangle that they have given as lambda can also be 2 times area of triangle RQM. I will call this point as M. So no need to find exactly this point P, rather only foot of perpendicular will also be fine, because these two has to be congruent triangle. So finding the area of this, multiplying it by 2 will give you lambda. Okay, now to find M, I think very standard method, and this kind of question has been asked multiple times in JEE. We will be taking this point N using this equation, calling this equal to mu. Okay, lambda is already given, so this N point I will be taking as mu comma mu plus 3 comma minus mu plus 1. So this is my point M in terms of mu, then mu plus 3 minus mu plus 1. Now this M point and Q, if you join them, the direction ratio of QM will be mu minus 3 comma mu plus 3 minus 3, so mu plus 6 actually, and minus mu only. Now this QM should be perpendicular to the line which is given in the question. Okay, and the line direction ratios are, I think, 1 and minus 1. So do the dot product. So we will be getting mu minus 3 plus mu plus 6 plus mu is equal to 0, which gives you value of mu equal to, because it will be 3, I think minus 1. So mu is equal to minus 1 is what we are getting. So if mu is minus 1, we will be able to get this M point as minus 1, 2, and I think 2. We can check minus 1. If you put in x coordinate, this ratio will come 1. 2 minus 3 upon 1 also minus 1, and 2 minus 1 upon minus 1 is also 1. So this point is definitely lying on this line. Now we can find area using half base into height, because QM can be found easily because we know this point Q and this point M, and we know this point R, so RM can also be found. Okay, so what will be QM? Let me see. QM will be root over 3 minus minus 1, so 4, so 16 after squaring, 2 minus 3, so 25, and 1 minus 2, so 1. I think this becomes equal to 42, root 42. Similarly, MR, if we find, this will be a distance between R and M, so 2 minus minus 1, 3, so 9, plus, I think once again 9, 5 minus 2, and once again 9. Okay, so this is root 27. Okay, so we were looking for lambda, that is 2 times the area of this triangle. So that means my lambda will become equal to half into 2, because 2 times we have to take into base. We can consider this as base, that is root 42. Any side you can take base and any side you can take as height. So 27. So 2 cancelled. From 27 and this 3, I think 9 will come out, because the 27 into 3 is 81. Root 81 is 9, and 6, root 6. Okay, that is my lambda. Then they are saying lambda square is equal to, that will be 81 into 36. Okay. One mistake is here. This is not 6. Actually, this is 7, because not 7 actually. 14. Sorry, this is 14. 14 into 3 is 42. So 81 into 14. Okay, so if you compare 14k, I think k value is equal to 81. That is the answer of this question. Okay, in 3D, especially 3D straight line, there are 2 kind of questions. One, taking point in terms of lambda. 2, finding shortest distance between 2 lines. Okay, so here I have taken a question where you have to take a point in terms of lambda or mu and then solve it. And this solving can be done based on what they are asking the question. In this case, they were asking the area of triangle. Okay, dear student, I am sharing with you test series link of JEE Mains, and this is the link to join Telegram channel of Iklavya. Please do it fast. Okay, now coming to question number 21. Here we are given a bag contains 8 balls whose colors are either white or black. Okay, 4 balls are drawn at random without replacement. It was found that 2 balls are white and other 2 balls are black. Probability that bag contains equal number of white and black balls. Okay, so dear students, when we are given bag is having 8 balls, their colors are either white or black. That means I can have 0 white and all 8 black. Then 1 white and 7 black and so on, and then 8 white and 0 black. So you can see there are total 9 scenarios that is possible in the bag. And without much information, I will assume these 9 situations are equally likely. Okay, now 4 balls are drawn at random without replacement. So you can take 4 balls at one go also, that is same thing if it is without replacement, and it is found that two balls are white and other 2 balls are black. Okay, now 2 balls white and 2 balls black means these first 2 scenarios will not be possible, and these 2 scenarios means where 8 where where 7 white and 1 black ball is there, that is also ruled out because 2 balls you cannot find. So only out of these 9, 5 possibilities will be there, and the probability of 2 balls white and 2 balls black will be equal to 1 upon 9 we can take outside. Okay, and first scenario is when 2 white and 6 black. That will be 2 white, selecting 2 white is just one way, and then 6C2 and divided by, that will be I think 8C2 plus, then it will be 3C2 into 5C2 upon 8C2 and so on. Okay, now they're asking probability that bag contains equal number of white and black balls. Means they're asking what will be the probability that there are 4 white and 4 black balls. So here there are 5 scenarios that will give you total probability of 2 white and 2 black balls. And there is just one scenario, let me write this here, 4C2 into 4C2 divided by 8C2. Okay, plus and so on. Okay, so how to find that probability? I think the required probability will be just keeping this in the numerator, that is 6 into 6. 4C2 is 6, so 6 into 6, and divided by all these things, that will be, the first one is I think 1 into 6C2, that is 15, and then this is 3 into 10, so 30, and 6 into 6, I think 36, and once again it will be 30, and then it will be 15. Okay, so I think I can divide by 6 for sure, so this will be 6 here, 15 plus 15, 30, and 33 times, so 90 plus 36 is 126, so divided by 6 will give you 21, so it becomes 2 upon 7. Is there any option like this? 2 upon 7, yes, there is one option, so answer of this question should be A. Okay, 30, 90, 126 and 6 divide, if we do, so it becomes 21 only. Yeah, so that is the answer. Now coming to the next question, 27 was 2 by 7 was the answer. 22. If m is the maximum value of the product of two integers when their sum is 66, okay, let the sample space S such that S equal to x belongs to Z, such that this x into 66 minus x is greater than or equal to 5 by 9m, and the event A equal to x belongs to S, such that x is a multiple of 3, then we have to find the probability of A. Okay, now please see how this question can be done. First of all, we need to know the value of m. Okay, m will be maximum when these two numbers, positive integers, both are equal. That means 33, 33. In fact, that can be proved using AOD, maximum minima, or it can be done using AMGM. These two numbers, when they are equal, then only their product will be equal. So their product will be maximum actually. So 33 square. Now we are looking for x into 66 minus x greater than or equal to, I think this will become 5 into 11 square. 33, so 3 into 11 whole square, 9 will cancel, so 5 into 11 whole square. Now, this will be a downward parabola, okay, and we want this product should be greater than or equal to 5 into 11 square. Now, let us see how this can be found 5 into 11 square, okay. So, 11 square means my x can be, I think, 11. I think x equal to 11 is giving you 11 into 55, that is correct, and 55 also give you same product. That means the set S, so set S is actually numbers from 11 till 55. From 11 till 55. Now they are asking the event A, and also these are integer numbers, not the entire set. So this will be 11 till 55. 11 till 55. 11, 12, 13, up to 55. Okay, and in this, I think there will be total, how many numbers should be there? I think 45 numbers. If you subtract the last two numbers, so 44 plus 1, because both numbers are inclusive, so 45 numbers are there in this S. Now, event A, so that is equal to x, so that x is the multiple of 3. Now, how many numbers are there which are multiple of 3? I think it starts with 12. Okay, then it will be 15, and so on. It is going till 54. So if I divide by 3, so this is 4, this is 5, and this is I think 18. 18 into 3 is 54. So 18 minus 4, 12. So there are 15 such numbers, both inclusive. 18 minus 4, 14 plus 1, 15. So 15 numbers are multiple of 3. Now they're asking the probability of A. So I think 15 upon 45, very simple. So answer of this question should be 2 upon 3. Okay, I think the difficult part here was this solving of this quadratic. Some of you may like to solve it using proper factorization of quadratic. That is also fine. But if you can observe that this is downward parabola and these points are satisfying it, then definitely between 11 and 55 all numbers will give you more than this 5 into 11 square. Now coming to this question, here we are given number of elements in the set of this A equal to AB 0D, so that I minus A whole cube is equal to I minus A, where I is 2 into 2 identity matrices. Now please see how this question can be done. I will tell you slightly, you can say different method. Just do the cube, both cube on the left side. So we will be getting I minus 3A plus 3A square minus A cube is equal to I minus A. This I will be cancelled and we will be getting A cube minus 3A square minus 2A equal to 0. Actually plus 2A equal to 0. So the factors of this can be written as A into A minus I into A minus 2I equal to 0. Now one very important thing here is that A minus 2I for all values of A, B, D that is given in this question, it would be A minus 2, B 0, D minus 2. And you can see the value of the determinant of A minus 2I will be A minus 2 into D minus 2. That cannot be equal to 0. That means A minus 2I is invertible matrix. Okay, so if I post multiply by its inverse, this will become I. So I will be getting A into A minus I is equal to null. Okay, so A square is equal to I here. Yeah, A square is equal to A here. Okay, now from this A, if I write A square, we will be getting A square here, and we will be getting B common, A plus D here, 0 here, and D square here. And we want this to be equal to A, B, 0, and D. Now, please see, this has to be equal to A square has to be equal to A, D square has to be equal to D, and this has to be equal to B. Now, for A and D, for A, B, D, let me write this way, what are the possible values here? So for A, B, D, and A square is equal to A means A can be 0, A can be 1, and similarly D can be 0, D can be 1. In fact, I'll write 4 possibilities here: A0, D0, A1, D0, A0, D1, and last possibility that is both 1, 1. Okay, now let's see what can be the possibility of B. Okay, so what I have done, I have written the values of A and D 0, 0, 1, 0, 0, 1 or 1, 1. Now if A and D are 0, 0, so from here I think this will become 0, so B has to be 0, there is no other option. Okay, if A plus D is 2, so this 2B equal to B is only possible if it is 0 here. But if A plus D is 1, okay, in both scenarios A1, D0 or otherwise, I think any value of B will work here. Any value of B will work here, which we can choose in 3 ways. So 3 ways for this and 3 ways for this. So total would be 1 plus 6. So the answer of this question should become equal to 8. Okay, so coming to the next question. Yeah, this question. Here we are given a function f natural number to real number given by this f1 plus 2 f2 plus 3 f3 and so on. If I write it once again, you can see it is f1 plus 2 f2 plus 3 f3 and so on plus x minus 1 into f of x minus 1 plus x into fx, and that is equal to x into x plus 1 into fx. Okay, now please see, if I consider sum up to this term, okay, and use this relation given in the question itself, I think this is nothing but one term less than what is given in this question. That means x will be reduced by one value. That means this entire sum will become equal to x minus 1 into x into f of x minus 1, okay, plus x into fx, x minus 2 into f of x minus 2 also, and so on, and here on. Why I chose this question for this session? The reason was, in very first attempt, I took 1 into f1 here. But we are given this relation is valid for x greater than or equal to 2. And when I was doing this way, I was getting it wrong. because f1 if you take as 1, so this will become equal to 1. But if you use this relation and if you try to find f of 2, so f of 2 means it will be f1 plus 2 f2, okay, will be equal to 2 into 3 into f2, and this will give you f2 equal to, you see, f1 is 1, and so 2 into 3, 6 minus 2, 4, f2 will be equal to, I think, 1. F2 is coming out to be 1 upon 4. Okay, so if f2 is 1 upon 4, and instead of 1 into f1, if I take this as 2 into f2, okay, you can see the value is coming out to be 1 upon 2, because f2 is 1 upon 4, 2 into f2 will be 1 upon 2. So this taking 1 into f1 is wrong, because this is giving you different result altogether. So here, all this product x into fx and so on, they are coming out to 1 upon 2. So my function fx is coming out to 1 upon 2x. And you can see that if you take x into fx is equal to 1, this original relation will not be satisfied. So be careful with all the conditions given in the question. Okay. Now they're asking 1 upon 2022 plus 2028. Okay, I think very simple question after that. So we have got fx equal to 1 upon 2x. Let me check once again. Yeah, correct. So now if I put these values, so 1 upon 2x means it will be 2 into 2022 plus 2 into 2028. So this will become equal to 2 into 40, I think 50. It's coming out to be 8100. I think that should be the correct answer of this question, that is C. Okay, so I have reached to my last question of this session. Okay, so the last question is fx is equal to 2 cos inverse plus 2 plus 4 cot inverse minus 3x square minus 2x plus 10. Very simple, but bit tricky, I will say. Question, just do the differentiation to know the range, because it's a continuous function in this domain minus 1 to 1. There's no point where it is discontinuous. So to know the range, we will check whether it is strictly increasing, strictly decreasing, or it is having some maximum minimum of the point. Okay, so if you do the differentiation here, so f dash x will be equal to minus 2 upon root over 1 minus x square plus minus 4 upon 1 plus x square minus 6x minus 2. Okay, now you can see there are so many minus signs here. So for x positive, definitely f dash x is negative. Okay, it is negative for all x that is between 0 to 1. That we can say directly. There is no, there is nothing hidden thing in this, directly negative. But for x positive also, please see, because my x square will take value between 0 to 1. 0 to 1. So this will be, less than minus 2. If you put x as 1, this will tend to infinite. If you put x is equal to 0, it will be minus 2. So it will be always less than minus 2, minus 2 to infinity. Now this thing, if you see, for x square between 1 to 0, this will be between minus 4 to minus 2. So this is again less than minus 2. This is again less than minus 2. Okay, because x square, if you take 1, then it will be minus 2. Otherwise, it will be less than minus 2. Okay. Now you can see this is less than minus 2, this is less than minus 2, okay, and minus 2 is here, and this 6x, if you take x as minus 1, then also this will be minus 6, okay. So with this minus sign, if I include, okay, this will be, I think, less than 6. Including this minus sign, I think this will be less than 6. If x is between 0 to minus 1, this entire thing will be between 0 to 6. So you can see this less than minus 2, this less than minus 2, and this is exactly minus 2. So the entire thing has to be negative even for those values where x is negative. So I can say f dash x is negative for all x, that is from minus 1 to 1. And then we can say it is a decreasing function. And if it's a decreasing function, so we are done. Fx is decreasing function. So we will be getting the maximum value. Maximum value will come at the first point. And x is equal to, I think, minus 1. Okay, that will be, when you put minus 1, so it will be 2 pi. Okay, if you put minus 1, I think this will be 4 into 3 pi by 4, so 3 pi. Okay, and this will be minus 3, this will be plus 2, and this will be plus 10. Okay, let me check. If we put minus 1, so it is pi, so 2 pi, minus 1, so 3 pi by 4, so 3 pi, minus 3, plus 2, 10. Yeah, that's correct. So maximum value will be, I think, 5 pi, and 12 minus 3, so 9, plus 9 actually. Okay, and minimum will come when x is equal to 1. Cos inverse 1 is 0. Cot inverse 1 is pi by 4. So this will be pi. This will be 3 only. This will be 2. This will be 10. This becomes equal to pi minus 5. Pi plus 5 actually. Minus 3 minus 2 minus 5 plus 10. So plus 5. Pi plus 5. Okay. And what we are looking for? 4a. A is smallest value. So this will be a. And this is biggest value. So b. So 4a means it will be 4 pi plus 20. 4a minus b, so 4a minus b. B is what? B is 5 pi plus 9. So this will be equal to 11 minus pi. 11 minus pi. So answer of this question should be B. Okay, so this completes all the question of this session. I hope you will like these questions. You would have liked this question. Please go through all the questions. If you're finding any difficulty, twice at least I will say, and try to solve it yourself after going through the solution, maybe after some time, so that these ideas which I have shared with you, you can apply them in other questions also. Okay, thank you so much. Thank you, bacho. Bye, and all the best for your exam.